Hello, this is Albert from AWB Electrical and Maintenance Services. Just going through a bit of a repair process on an Onan generator. So on this generator, this is like 11 kVA generator. Can you see the model number? Is it going to focus in or not? There we go, so that's the model number of the generator. So it's a basic generator. Like reality, these things are the same whether they're 110, 220, 230, 50 or 60 hertz. The process is the same with diagnosing these things. So basically with these, there's a control board which fits here, which is this guy here. This one's been repaired partially. But the main thing is with these, the biggest thing I find is a lot of people go, it's a control board or it's this or it's that, and they just start throwing parts at it, and then you end up spending $10,000 worth of parts with a generator that still doesn't work. The biggest thing with these things is it's actually very easy. You can actually see them there, so they're paired. So I've written on them and that, but on this lid here there's a schematic on it which shows you all the wiring. These Onans are unique and small generators in the sense that they've got one, a field winding, two, they've got a quadrature winding, and three, they've got an AC sense winding. So on these, this control board here, it all goes into here. So these two are pretty much, these connectors on the here are pretty much like your start, stop, all that stuff for the generator and other functions. And then most of the high level functions for the generator end are through this plug here. But you'll see that in the schematic. So J1, J2, J3. And with these pairs here, I said all I do is you just pop this off, this guy here, and then you pop the pins out, and then you can force it. So all I do with these Onans is you take the fuel actuator, you give it in voltage. So this is a 12 volt generator, so you give 12 volts directly in there, which just take off the battery. And then when you start it, it'll start, but it will keep running, and then you just have to use the manual lever to stop it. Pretty easy. So when it's running, we can then cheat, we can shove voltage into the field windings. You can try both ways in DC. So some might want a little bit more, but the main thing with them, if you're shoving DC and you're getting an AC voltage out of the unit, and it's sympathizing through the quadrature and the AC sense, then your fault is not in the alternator end of the generator, it's the board. But if you put voltage into your field and then it doesn't want to come up, then your fault is in your alternator end, not your board. So in this instance here, we had a fault partially because you can see this rust here. Previous owner didn't look after the boat, and there was salt water getting sprayed through here, and we had 1, 2, 3, 4 capacitors that had failed on this board. These are normally resin encapsulated, so I had to dig this all out. I used actually a crock pot to heat it up, to soften it up, and then it came out with a plastic scraper to get that all out, so we could then lift the board out. And there's 3 studs, 1, 2, 3 there, and then there's 6 screws across the front here. And once you lift that out, you can then see what's going on with the board and identify it. But basically the field driving circuit is through here. So that's your SCR, so that was all tested fine. Caps, resistors, diodes, so forth, it's all pretty much, this is basically it here. So yeah, so normally this board in Australia is about $3,500. So there's not $3,500 worth of parts to repair that with what we've replaced here. But what happened was the old capacitors, they'd actually swelled and exploded. The ends had actually mushroomed out on them. And yeah, and that seems to be the fault so far. So fingers crossed, that's it. So the main thing is we're just doing a test run with it, so it's got to go back in. And then once it's all good, which actually it has run on it, but we just put it in for a short period of time because this boat is going out on a fishing comp in 2 days, so it just needs to run for the short term, and we haven't got any availability of silicon, resin to throw back in this. We're a bit short in Townsville. Currently, that's a COVID thing, I guess. Since COVID, no one wants to stock anything. So this board's been heavily varnished just to get it by for the moment. I've got plastic screws studding it up at the corners there, but that means it's fairly solid. So we'll throw that back in, and that's ready to go again for this weekend's fishing competition. And then it's back out after that and a proper repair on it. So yeah, so these Onans aren't as hard to diagnose if you understand the basics of how to run the engine from basically here to here. If you can force that and understand that, then the other side of it's just like testing a normal generator, and that's pretty easy. So if someone's going, I think, for parts, they don't understand how to do that, and they obviously don't have an understanding of how to run a generator properly, to force it to run it outside this, because there's nothing really here. There's no electronic actuators. It's still a mechanical pump assembly with a locked throttle there on it. So this is no voodoo science here. It's just an old Kubota engine. So unless it's the new fancy ones, these are very easy to diagnose if you understand them. Like normally, typically I can diagnose one of these if I got readily access to the front. So unfortunately for this one here, you've got to pull the fridge out to get to it. It takes a bit longer because you've got to pull the covers off, and it's a bad installation here with all this gear on the top. So if everything's out and apart and there, it's ready access, I can normally diagnose this in about 30 minutes. So yeah, if there's any questions, post them up and I'll try and answer them. Thanks.